The Amazon region includes the planet's largest tropical forest, covering 7 million square kilometers within 9 countries. This region, where 24 million people live, also contains the largest freshwater reserve on Earth and biogeochemical cycles occurring with such magnitude that impacts global atmosphere and climate. In the last few decades, governments, institutions, and the scientific community have come to realize the overall strategic importance of the natural processes occurring in Amazonia, and are just now beginning to understand the possible consequences to its delicate balance. From this understanding, the Large-Scale Biosphere-Atmosphere Experiment in Amazonia, or LBA, was conceived, a massive Brazilian research endeavor developed in partnership with international cooperation to carry out and coordinate until 2008 over 100 research projects aimed at uncovering and understanding how the Amazonian ecosystem works. The LBA primary goal is to understand the climatologic, ecological, biogeochemical, and hydrological systems of Amazonia, also evaluating the impact of land use changes and explaining the interactions between Amazonia and the global biogeophysical system. In synthesis, the LBA hopes to answer 2 essential and complex questions. How does Amazonia currently function as a regional unit? How will changes in land use and climate affect the biological, chemical, and physical functioning of Amazonia, including the sustainability and development of the region and its influence on global climate? To answer, LBA has set up multidisciplinary teams that integrate physical, chemical, biological, and human sciences. Amazonia has never seen such large volume of research projects, capital investments, and equipment contribution. Laboratories across the entire country, along with remote sensing airplanes, field stations, a network of sensor towers throughout the territory, and satellite data, are all working in a highly coordinated way to collect and intersect data. Research projects are now in progress over 6 Brazilian states: Pará, Amazonas, Acre, Rondônia, Mato Grosso, and Tocantins, as well as the Federal District, and in 5 Amazonian countries: Peru, Bolivia, Ecuador, Colombia, and Venezuela. Today, the LBA program is one of the most important examples of scientific cooperation ever created. With some help from international partners, LBA is primarily funded by the Brazilian Ministry of Science and Technology, by NASA, the official space research agency of the United States, by the European Community, and by other sponsoring agencies. The LBA program is already a scientific success. Over 100 projects are being carried out and are surfacing cutting-edge science. Over 1,000 researchers from Brazilian institutions, almost 800 from Amazonian countries and American institutions, and 8 European countries are working cohesively together on the program. INPA, the National Institute of Amazonia Research, is now in charge of the scientific coordination of the entire LBA program, which has been carefully developed by 280 partner institutions. The LBA focuses on 7 primary research areas: physical climate, carbon storage and exchange, biogeochemistry, atmospheric chemistry, land surface hydrology and water chemistry, land use, land cover change, and human dimensions and climate change. Physical climate includes meteorological and hydrological research on the study of watersheds to understand longitudinal and spatial changes in energy and water fluxes, extrapolating them from small areas to the rest of the Amazonian basin. The study of carbon storage and exchange will hopefully clarify whether Amazonia works as a net carbon sink, meaning it absorbs significant volumes of this major greenhouse gas from the atmosphere. Scientists also want to learn how much carbon is released as a result of forest slash and burn, selective logging, land cover and land use changes, and conversion from forest to pasture or agriculture. The biogeochemistry component of this program focuses on nutrient cycling, the contribution of nutrients from the atmosphere and emissions of greenhouse gases from natural, secondary forests, and managed lands. Another important field of LBA is atmospheric chemistry, which aims at understanding the influence the Amazon may have on tropical and global concentrations of ozone, as well as other gases and aerosols, which are suspended particles surrounded by condensed moisture which forms clouds. Land surface hydrology and water chemistry studies evaluate the Amazon basin quantity and chemistry of water, its reservoirs and fluxes, and what determines the movement of water in soil and in streams. The land use and land cover component studies changes from natural vegetation to agricultural crops and their physical and socioeconomic root causes. Finally, studies on human dimensions and climate change investigate how human activities transform the Amazonia and how its impact affects local population. The complexity of these studies led the LBA program to integrate a large range of interdisciplinary knowledge areas that have afforded enormous advances towards answering questions about Amazonia still debated all over the world. Furthermore, LBA has already made fundamental strides towards the formation of qualified human resources. By the end of 2006, about 400 Brazilian masters and doctors of science with expertise on the study of Amazonian biosphere and atmosphere will have graduated and will be ready to contribute to the sustainable development of the region. Research networks in Brazil and other Amazonian encompassing countries are expected to expand and continue to improve. The public policy stakeholders will have scientific data to aid them in evaluating the impact of changing the energy, water, carbon, nutrients, and gas fluxes on the Amazonian atmosphere, hydrosphere, and biosphere. This knowledge should also help them plan for the sustainable use of the natural resources of the planet's largest tropical forest.